Hello and welcome to this new tutorial on Emgu CV, and in this tutorial I am going to show you how can we process only a portion of an image by selecting an ROI using our mouse. So let us get started. I have created a project and configured it to use Emgu CV 4.2. You can see my previous tutorial in which I have created this project and how can we use this mouse to select a region of interest. And in this tutorial I am just going to show you how can we process that region of interest and show it in the original image itself. So I'm just going to do the process and I edit. So this is the portion that is going to select the region of ROI, and which has already been shown in my previous video. You can check the Gaussian blur. So I'm just going to do the Gaussian blur on that portion of the image, and I also show you how can we apply the Kenny edges on ROI region and display it in the image. So what I'm going to do is double click on this Gaussian blur, and as I explained in my previous video that we have selected already a region of interest in this rectangle by drawing the region of interest using the mouse on the image. So once we have, in this tutorial assumes that we have the region of interest in this rectangle. So now I am going to blur that region of interest and display it again in the picture box. So first thing that I'm going to do is to make sure that I don't have any exceptions, and in that case my program should not crash. So that's why I'm using try catch. The first thing I should check here is whether my picture box has some image or not. So if it is equals to null, so it means that user has not selected any of the images. Then in that case I'm returning from further processing. And the second thing I need to make sure is that my rectangle is also not equal to rectangle.empty. For example, if it is equal to rectangle.empty, then in that case I will also not do anything. So these two things are important for us to process further. So I should have an image and the rectangle or the ROI has already been selected. Now I am going to read the image from my picture box. So there is a different way little bit in 4.2. So I just create a new bitmap first. So I just want to create a bitmap from the picture box image. So picture box one.image, and then I can convert it into a 2A image. So, and which type of image is BGR? I'm just considering it to be of type byte, and that's it. So now this one has become a data structure of my Emgu CV. And once I have the image, I am interested in only the region of the interest that the user has selected. So I'm going to do img.roi region of interest is equal to the rectangle which the user has already selected. And then we can say img2 is equal to rectangle img.copy. So this one will only copy the region of interest. So once we select the region of the interest, the copy will only copy that image from within the region of the interest. So this img will contain only the image of this ROI, not the image portion that is outside of this ROI. So once we have the image copied here, now we can perform some sort of, you can say, smoothing. For example, I can say I am smooth. So since we are applying the Gaussian smoothing, so img2 dot, we can smooth the image by using Gaussian, or you can blur it or whatever. So in order to show it like if it is doing smoothing or not, I'm selecting a kernel size of very large kernel size so that we can easily see the smoothing that has been done in the image. So normally we should select a smaller number if you want less blurring. Just I want to show it to you. Now since img2 is a new object in our memory, and that image has been basically blurred and the results have been stored in img smooth. Now I just want this smooth information to be in my original image. Here is the image, which is the img, which we read the complete or the whole image. So how can we do that? There may be many possibilities. One of the possibilities that I want to do is the region of the interest or the area which has been selected. I just want to set all those values in that region of interest to be equal to 1, for example. So what can I do is img.set values. There is a function which says set values, and it is automatically saying it is a BGR image. So we can create a new BGR, and if it is a gray image, we need to create a gray image and provide only one value. So this is a 3-channel image, so I'm going to say 1 1 1 for all those channels. So what it will do is, since still we have the region of interest selected, we set all the values equal to 1 only within that region of interest. Now what I want to do is, with this image I want to do an in-memory multiplication. So remember that this in-memory multiplication is directly changing my original image. So that's why underscore multiply that I am selecting, and I am multiplying it with img smooth. So you can see that within the region of interest I have set all the pixels is equal to 1, and when I multiply all the pixels of my img smooth with these ones, so technically you can say that I am making the values of this img where all these values are equal to 1 when we multiply with img. So these values will be written directly into my img. So we are just multiplying with 1. We'll copy these images values. So this one will be doing what is just showing my smooth image in my ROI. Now we can remove the ROI from this original image is equal to rectangle dot empty, and we can show this one in my picture box dot image is equal to img dot as bitmap or to bitmap, whatever you want. And as I said, this one is only applicable when you install this package for native Windows packages, runtime.windows. And one more thing that just I want to display it in my tree view also. So what I need to do is, I have created this method in my previous tutorial. So add image, and this is the image that I want to add, and we can give it a name like process Gaussian blurred, Gaussian blur, for example. And let us run this application. So let us select an image and the building that I'm going to select. So the first thing that we need to do is select an ROI. So I am selecting, let's say, this region of the interest, and in the last I showed you get region of interest, so it will show only the region of interest. And now I can do the Gaussian blur. So if you look at this image, the area which we processed, that is coming as the Gaussian blur. So not the rest of the area. Sometimes we may need to do processing in only a part of the image, not all of the image. So this is how we can do that. So this is the region of interest, and this is the original image, and these all images are stored in my img list dictionary, which I have created to store all my outputs and the input images. So you can see this is how we can do the Gaussian blur. We can also do the same thing for whatever operation that we want to perform. For example, I want to do the canny edge detection on that portion. So what I will do is only few things will be changed. So from my Gaussian blur, I will copy all the code and I will paste it here. And the only thing that I want to change is in this area. So instead of the Gaussian blur, we now maybe I will keep the Gaussian blur. First I will blur the image, let's say using a smaller kernel, and then I want to find the canny edge. So the canny edge is expecting some threshold for the initial segments or the strong. Let's say I want to consider the strong edges with 100, and for the weak edges, let's say I selected 50, for example. So this one.
Now, this is basically a grayscale image, and we need to convert it into an RGB image. And as I want to do some multiplication operation with the original image, so what I can do is img and bgr is equal to img dot convert. We can use this convert function, and I want to convert it into bgr. So once we have the BGR image, I can set the values of the original image in the ROI equal to 1. So I can write something img.setValues, and these values can be equal to new BGR, and I can say 111, and here's BGR. Okay, and then we can do an in-memory multiplication so that we can update the values within this region of interest by multiplying them imgbgr. Okay, so you can see that we have set these multiply with 1, so all the values of img will basically be copied technically into img. So once we have the image and we have changed those pixels in the ROI, we can reset the ROI back to the original size. So rectangle dot empty. And now we can show in the picture box one dot image is equal to img dot as bitmap. And then we can add this one in our list of dictionary of images. So I can say img, and we can just name it like Kenny H. That's it. So let us see the results. Maximize it, and just I'm going to open an image and then select this building image and select an ROI from here. Let's say like this. And now we can find the canny edge. You can see that only that portion has selected the canny edge. Similarly, we can also test for the Gaussian blur. You can see that it can do the Gaussian blur. The results you have been already stored separately. This is the canny, so you can display all the results like this in the application. So that's it for this tutorial, and I hope you enjoyed the video and hope to see you in another video.